Фух, ну чё. Hello everyone. Hello. Welcome. Um, okay, let me show you where we left off yesterday. I'm not sure if that's the correct way to say, but yeah, I will just show what we ended up yesterday with. This. Take a look at this. Uh, If you can see, there is a ball texture, a quad, and a circle, and this bean. So, if I generalized, what I did is that yesterday I've created a system where I can load textures, load first the image, and then based on that create the texture. Yeah, so I've loaded two images, bean and the ball. And yeah, sure. Here I have this butcher. Butcher is a simple system, if I can say so, to draw like to collect the rectangle data, and then batch draw it in a single draw call. Yeah, not very difficult thing to implement, but actually, here we have a few problems. And what do I mean by problems? Take a look at this bean. Take a look at this bean. And now take a look at this bean. I'm not sure. I'm not sure if you can see the difference, but there is a difference. This bean is much lighter than this one. And this ball, wait a second. This ball. This ball right here, it is lighter. Uh, again, I'm not sure if I'm saying this correctly in English, but yeah, this ball is much brighter than this one. Yeah, and that is bad. And the reason why it is happening is that when I'm loading the image, wait a second, main. When I'm loading the image, I'm doing this right here. I just copy all the pixels, and actually I flip the image vertically. Yeah, the problem here is that all images that we are seeing right here, they are all in the sRGB color space. That is important. You know, because our eye receives like linear light, and our eye like transforms it, slightly modifies. Our eye is much more sensitive to darker colors and little bit less sensitive to brighter colors. But the thing is, OpenGL operates on linear values, and yeah. So let me think about it as this for a second. The problem is that also I didn't mention that I've enabled frame buffer sRGB. That I've enabled sRGB frame buffer. What does that mean? It means that everything that I draw, to the main frame buffer, it will be converted to the sRGB color space. And the problem with my images is that I've loaded the image in the sRGB color space. I pass it to the shader draws it, and then once again it gets converted to the sRGB color space. Like effectively I convert to sRGB color space twice. I'm not sure if that's the correct thing to say, but yeah, I need my images be in linear space so that when I draw them to the screen, they are converted back to the sRGB color space. And yeah, I think everything will work fine. And yeah, I think that's a doable thing for me. I think I'm not. I think I will be able to do that, but I'm not sure. Yeah. So what do we have here? We will definitely need to modify this, but actually, wait a second. I want. Let's create a structure texture load params. And yeah, let's create a field. We will call it, I don't know, image is in linear. Image has linear colors. And let's say that by default it is false because oh no, what am I doing? Bool equals false. Uh, that's not necessary, but yeah, I will write that explicitly or implicitly. I'm not very good at English, as you can see. So, most often, images are stored in not in linear space, but in like in sRGB space. How do I how do I how do I explain this? Wait a second. There is a difference between like a color image and like linear image. Linear image might be used for something like, I don't know, metallic map, specular map, where there is a single float value and it is linear. It should go linearly. Uh, yeah, sorry. But all the color images we see, like for example this one, our eye perceives this light and it modifies it. So basically, uh, we are seeing what we see on the screen, like it's like our perception of what the linear value actually is. So the yeah. Okay. So what what am I trying to say is that um, sometimes it will be necessary to load image like linearly like this, you know, and sometimes we need to convert the image from sRGB color space to linear. And yeah, Um, yeah, that's it. Um, so what should I do? What should I do? Yeah, I will just use those texture load params. Let's say will be a pointer to texture load params. Okay. And here, let's say that if load params texture has linear colors, okay. Otherwise, I will do a slightly different path. And what I will do exactly is that first let's read this color, like sRGB color int will be equal to this, which will, yeah, we'll basically get an int. I believe I have this utility to unpack RGBA color to U30. No, sorry. This is unpack. Yeah, I will unpack this RGBA from U32. Yeah, okay. Okay. Main, right? So sRGB unpacked color will be unpack color from U32. I already forgot the name of this function, and yeah, let's just pass this one. Okay, and so what it gives us? It gives us this vector 4. Nice. Now I just need to convert this to the oh my god, I just hope that I understand all those things correctly. Because actually I'm not sure. So yeah, I'm unpacking this color from U32. This image is in the sRGB space, so I need to convert sRGB to linear, and I do that by that's not necessarily the most correct way to do those things, but linear color will be equal. Here I have the utility to convert. Wait a second. Oh, so I've created all those utilities without even thinking how I will use them. Now it's finally time to use them. So yeah, linear to sRGB. No, I need sRGB to linear. But it will, yeah, I think this is what I need. So yeah, I just need to convert linear color will be equal to sRGB to linear, sRGB unpacked color. Okay, and now I need to pack this one once again. Packed color will be equal to pack. Oh, sorry. Oh, sorry. Pack RGBA to U32. I'm not sure if that's the correct function, but yeah, linear color. And now I need to write it to the DST line. Dot star equal packet color. I can do this in one line. Nice. And yeah, let's just try maybe run this thing. I will of course get the errors that I cannot load because I didn't pass those parameters at the moment. Texture load params. This should be a struct. The next error is not a member. What? Image has. Let's call it just has linear colors. Yeah. Load params. Load params. Sorry. Sorry. Unpack colors. Unpack RGBA from U32. I used not the function that I was intended to. Unpack sRGB RGBA from U32. Pack RGBA to U32. Left argument of a shift operation must be of an integer type. Wait a second. Oh my god. Oh my god. Oh my god. Oh my god. That was bad. I don't know how Dry didn't notify me about this error previously. Yeah, fine. Oh my god, nice. Yeah, it seems like I understood this problem correctly because right now, as you can see, Hmm. I'm still not sure. I'm still not sure. Hmm. It looks good. It looks good. It looks much better. Yeah. Yeah, it is fine. Nice. So nice. We have nice textures, and I like it. I really, really like it. Hmm. Okay. So, um, yeah, I'm happy. I'm happy with that. The only problem for now is that I have this branch right here. And also, I think. Uh, I think there are quite a few problems with my approach. Why do I even have this image? Like currently I'm thinking, like, mm, is there any reason that I should have this image struct? Why just I don't use this texture and load texture without this intermediate image step? And I think it is quite reasonable question. I don't need I think I don't need uh, this image because for my entire life I've been like splitting them, but now I'm thinking like, hmm, there's actually no reason I think to have the image because everything I do in code is just use the graphics texture handle and that's it. Hmm. Yeah. I will just get rid of this. There will be um, no image. I believe, if I remember correctly, this popular library Raylib does the same thing. It splits into image and texture. I'm not sure. Uh, I'm not sure if I need that. Yeah, I'm not sure. I will remove everything of this. I will of course do what? I will copy everything of this. I will remove this. Hmm. Uh, hmm. Create texture. Maybe load texture will be a more correct thing to do. STBI image free. Yeah, this should happen here, but in the end, when I've allocated the texture on the GPU. Yeah, I think I can, when I've allocated the texture on the GPU, I can free the image itself, I think. Yeah, so here I've allocated it, data, and I can free the data right now. Free data. Okay. I don't need this image, I can just use a path as a string and load params is a pointer to texture, load params. This one will be now called load texture. X, Y. There is no image, so X and Y. Image data, just the data. Okay. Nice. Okay. I think it works better now, but I still don't like this code separation. And the problem is that I don't want to also have this I do not also want to have if inside the loop because it is not really performant. What if I want to not flip the image vertically? So many questions. So many questions. Oh my god. Flip vertically. Bool equal to true. Yeah. So Interesting. Wait a second. So by default, I want to flip vertically, which I do right now at the moment. But I want to, I'm thinking, can I do this somehow? Does STBI flip vertically? No. STBI load. Yeah, so I just want to use STBI. I think there was a possibility to do that in STBI, but I'm not sure if they did this in this one, in this binding. Flip. Oh, yeah, here it is. Flip the image vertically so that the first pixel in the output array is the bottom left. Yeah, this is what I need. Yeah. Um, main jai. Yeah. Premultiply. For image formats that explicitly notate that they have premultiplied alpha, we just return the colors as stored in the file. Set this flag to force on premultiplication. Results are undefined if on premultiply overflow. Okay, I don't think I need that at the moment. So, and if I believe I can now do it the usual, like the simple way, plus J. Here I just copy the color. Yeah. Um, so, what do I do next? I'm just trying to figure out if I should do something here, and I'm not sure. Let's. Hmm. Hmm. Create texture for image data. Hmm. Okay. Oh, okay. Never mind. I just wanted to maybe split this one into a separate function because texture creation may happen in different parts of my rendering pipeline, and yeah. Okay. Never mind at this point. What I want to do also at the moment is to add support for like, you know, nearest filtering. At the moment I just do the linear filtering, and there will be a problem, and I will actually show you. Let's Mario texture, load texture, data, Mario, PNG, load params. Okay. Let's see. I think I had one somewhere. Um, I have Mario, but it's like it's too wide. I just want a little pixel image. Very small. I want very small pixelated image. Hmm. Maybe I should draw one of myself. Why not? Let's do it. Maybe it will help me to understand Sprite better. Sprite is a program for making like images. File, new. I don't know. Okay, let's make it 64. Grace, no, advanced. Okay. Yeah. Let's draw Mario. Yeah, this will be my drawing. This will be my version of Mario. Oh, no. No. So. Okay. Okay. Skin will be here, here, 3 here, 4 from here. Okay. 1, 2, 3. Okay. 4, 1. Like this. This, and this. Nice. Yeah. Okay. Nice. This is the head. Now like this. Hmm. Okay, and two a little calm and relaxing drawing. Um, hmm. Eraser. How? 1 pixel. Yeah. Okay. Like this. Now. Hmm. Okay, and now the fist. Seems that I did something wrong, but I. Oh. Oh. I don't understand. Ah. I should have done this here. Okay. Like this. Here will be a skin. Yeah. This will be my Mario. Yeah. 16 pixels was enough. Sprite size 16. No. No. Canvas size 16. Yeah. Yeah. File. Save as ddev. Try projects, data, Mario. Okay. Now, let's load this Mario and let's draw it. Push texture. -2, 0. Um, hmm. Whoa, wait, load params, flip vertically. Yeah, and here you can see the problem. Here you can see the problem actually. The problem is that our Mario is, I don't know, is like a melting butter. Yeah, it looks weird. So, yeah, and this is because of the texture filtering, because I use linear, but I need to use nearest, because like, yeah, because we need to search like for the nearest pixels. Yeah, and I need an option to handle that. Filtering is nearest. Bool equals true. Yeah. No, sorry, equals false. Equals false by default. Yeah, and here, if load params filtering is nearest, filtering mode equal if x, I believe if x will do the thing. If x load params filtering is nearest, then GL nearest, otherwise GL linear. Yeah. Yeah, and let's use this one. Sorry. Then else. Sorry. Weird, but okay. Wait a second. GL text. GL int, right? Of type GL int. Interesting. But okay. Okay. And finally I need to create a separate pixelated load params. Texture load params. Load params filtering. Filtering is nearest. Will be equal to true. And of course I need to use those load params. Yeah, finally I have this Mario. And that's good. That's good. Whew. Oh, nice. I really like it. I really like it. Yeah. Oh my god. This is like super nice. Now, what? Maybe let's do let's implement the map generation maybe because yeah, let's see if we have a problem. What if I when I push the ball, what if I use this size of the ball? Huh. 1. If I use 0.5, you see, I'm not sure if you can see that on the stream, but this image becomes like very noisy, very very bad. I'm not sure if you can see this, but yeah, like if it was squashed. Yeah. So a map is, if I remember correctly, is a way to avoid that behavior. It's like a way to pre-cache, pre-compute this is like a way to pre-compute smaller textures than your texture and use those when the program is able to. Yeah. Yeah, so I want to let's see, generate mips bool equal to true. Yeah, let's set it to true by default, maybe, or maybe not. Maybe let's say that it will be equal to false. Now let's say that if load params generate MIPS GL MIP map. Wait a second. GL generate MIP map. GL texture to D. Okay. Now I need to use those parameters. Generate MIPS equal to true. Yeah, so what do I have here? Let's see. I want to create a possibility, maybe to scale this image over time, and yeah, maybe it will help us to understand the degree to which the problem appears. For now, I will just comment those things so that we have our 3 images and what so yeah, let's see. SDL get query performance counter, something like that. Get performance counter. Yeah, this is what I need. So I need to query performance frequency. SDL. Performance frequency equal to SDL get performance frequency. Now let's say 1 over performance frequency will be equal to, let's say it will be a double value, float 64. It will be equal to 1 divided by cast float 64 performance frequency. Now in the end of the frame, let's do the following thing. Measure time at the end of the frame. Now let's get the performance counter in the beginning. Begin clock will be equal to SDL get performance counter clocks elapsed will be equal to SDL get performance counter minus begin clock. And yeah, now we can convert that to time by time elapsed. Time elapsed equal to cost float 64 clocks elapsed times 1 over performance frequency, and let's say that app delta time equal time elapsed. Yeah, now we need to create this field for the delta time. Delta time is of type float, time is of type float 64, let's say. Yeah. And what? Now let's say that application time equal to 0, of course, application delta time. Let's say it will be equal to 1 divided by 60 by default for the first frame. Okay. Time elapsed application time plus equal time elapsed. DT. Cost float 32. Okay, and now we can use those times to create like a sine wave, for example, something like that. So plus sine, let's say 0.5 times sine Application time. Uh-huh. Uh-huh. Interesting. Fine. Hmm. Okay, the problem is this function. Maybe I can put something like that. Yeah. I think on this ball I still like have the this very same problem. Huh. Yeah, and that is really a problem. Um, and I'm not sure. I think I did everything I could. And I thought it will fix the problem. What is the size of this ball texture? I'm wondering. It is very big, very big. I think that's the reason why I see this problem. Generate MIPS. Will generate MIP map. Yeah, okay. I'm not sure. Maybe even MIP maps cannot help with that. I'm not really sure. Okay. So, for now, I will leave for a minute and you can enjoy this this very silly but nice animation. Yeah. I see this flickering. I'm not sure if you can see that on the stream, but there is a flickering on this ball, and yeah, it is not nice. Yeah. Yeah, that is actually not the only problem here. When this image is scaled, you can see this flickering um, of the pixels. Huh. Hmm. Hmm. Filtering mode. Hmm. Say that if load params should generate MIPS, else let's see. Hmm. Hmm. So, yeah, let's maybe ask ChatGPT. Wait a second. Okay. Yeah. When using GL generate MIP map, should I use different filtering modes than I use usually? Yes. MIP maps are only used if your minification filter is set to MIP map enabled mode. Okay, yeah, so this is what I wanted to see. Yeah, so let's see. Filtering mode. If I should not generate MIPS, I do this. Here, if if this, let me drink water, and I should also take a pill. Okay, so if load params filtering is nearest, um, so let's see. If the filtering is nearest, um, let's create two variables: magnification filtering mode glint min filtering mode, magnification filtering mode equal to min. Magnification filtering mode. Okay, so I don't know. really. If filtering is linear, then magnification filtering mode may stay GL linear, but minification filtering mode should be GL linear, map linear, right? And what if I use mip maps for the nearest filtering? Oh, I don't know. GL nearest mip map nearest. Yeah. Okay. Hmm. Ah, never mind. I don't know what's the problem. Uh-huh. GL nearest. Okay. Let's see. Oh, nice. Oh, yeah. Oh, this is very good. Very good for this ball. Oh my god. Very nice. Yeah. Yeah. Yeah, very good, very good. So, I guess I should now, I guess this will be a very good ending. And the logical thing to do now is to implement like this pixel art image renderer, which will render like without those pixel scaling artifacts. You will definitely not be able to see this on the stream, I believe. But when this image scales, especially when those pixels are very when the image finishes it's scaling up or scaling down, um, those pixels are flickering, and yeah, this is very bad. Let's maybe draw Luigi, Luigi pixel art. Yeah. Yeah, nice. I want to draw Luigi because I think it will be more fun to have them both here. Oh no, maybe Princess Peach pixel art. um, I'm not sure if I understand this. Um, this will this one will be difficult. Maybe this one. Hmm. Okay, I will draw this one. I just want file new. Hmm. How many pixels do we need? 2, 2, 2, 2, 8. 10, 12, 14, 16, 20. Okay. 24 by 24 maybe. Maybe this will be enough. Now we need to now we need to draw. Maybe let's select a color for the crown. Maybe. Let's see. Okay. Now the hair. Okay. Yeah. Like this. Here. Here. Now to here. 3, 1. 4. Here. Okay. Like this. Nice. Nice. Okay. Now the skin color. Okay. Nice. Okay. Now the dress. Like this. The skin here and here. Okay. Like this. Okay, nice, nice. Very good, very good. I'm not very sure, but it seems like she has those as well. Well, sprite, canvas size, like this. Um, 12. Okay. File, save as. PNG Peach. Princess Peach. Okay, and yeah, I need to load Peach texture. Pixelated load params. Yeah, and let's draw it. Instead of those are fine. Peach texture. Of course, I need okay. Let's push 2 more of them. Minus 1, 1, minus 1, minus 1. And let's say their scale will be very small as well. Yeah, it is very you know, it is very noticeable when the image scales. You can see those pixels growing. Oh my god, that looks so bad. Now I need to implement something to avoid that. Okay. Yeah. If I if I'm making a 2D game, I really need to fix that. And if I'm making a 2D engine, yeah. I'm making a pixel art game, and my pixels behave very weird when scaling. Do you understand what I mean? Yeah, picture shimmer or scroll. The pixel art only looks correct when one screen pixel an exact multiple of one texture pixel. Uh-huh. Hmm. If I remember correctly, I've implemented Pixel Perfect Shader. Oh my god, I'm not sure. Or maybe I did that in Odin. I don't remember. In my Odin project. Res models monkey source shaders. UI. Uh, Tone mapping UI. Shadow. I thought it was here. Maybe not. Source. Pixel art. Yeah. Yeah. Whew, oh my god. I do not remember those computations. I do not want to like get this code and like say that everything worked. I need to refresh that in my memory. I want to understand that better. Yeah, I will definitely do that now. Like, what if I think about this logically? How can I fix that? Hmm. Huh. I do not understand that. Wait a second, let me see. Maybe I will try to find the article about that. Texel coordinate, GL fragment texture. This is UV or what? I will assume that those are UV. Texture size. Texture size. Let's do the thing that ChatGPT advised. Let's not. Let's generate MIPS only when the filtering is linear. And no load params. Filtering is nearest. Okay. If generate MIPS and no filtering is nearest, yeah. Yeah, I think this is the correct way to do it. Yeah, let's see if this makes a difference. Not really. I still see this problem. Yeah. Let's Google for pixel perfect pixel art shader. Hmm. 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 Uh, I do not want like the solution. I want an explanation. Hmm. Okay. Yeah. Um, Now I'm thinking, why didn't I like save the link somewhere? Um, Maybe I did. Um, Not really. Pixel perfect art shader explained. Maybe I should Google differently. Small pixel art. Pixel art jitter. No. No. Oh my god. That's struggling. Hmm. Okay. Let's see. Maybe I cannot find the article which I used to implement this one. Um, Texture size. Okay, I get the texture size, the original texture size. Okay, now I get the texel coordinate. Inside the texture. Location within texel. Okay. Texels per pixel. Texture size. Mhm. Yeah, so here, what do I calculate? Here I calculate how much pixels we have per pixel, right? Then I clamp. What? Location. No, I do not understand. Location within Texel. Wait a second, I will punish my cat. Okay, okay, maybe we should ask. Can you maybe explain pixel perfect shaders? To align with the pixel grid. Shader snaps texture coordinates your position to the script. Texel steps. Basic pixel perfect. Fragment shader. No, I think maybe we should ask him to see what this shader is doing and maybe explain it to us. No, sorry. What does this shader do? Smooth pixel scaling, anti-alist, nearest filtering. It's basically convert UV texel space. Find position inside a pixel. So now the shader knows where inside a pixel you are. Compute how many texels map to one screen pixel. Yeah. Wait a second. Texture size on screen. Okay, so okay. How many pixels map? Yeah, I understand that, pixels per pixel. Okay, then location within pixel divided by pixels per pixel. Location within pixel. Location. Location within pixel. Times texture size. Okay. Location within pixel. Yeah. Now, pixels per pixel. We calculate how much pixels do we have per screen pixel. Okay. Times pixels per pixel. I do not understand this division. Ah, I see how much. No, wait a second. Like it seems to me that we are like checking how much are we, like how much close are we to the edge of this pixel. Yeah, I see. It is very clever. Yeah, we see how much close are we to the edge of the pixel. Yeah. Oh my god. Result texture coordinate. Yeah, and we see from both sides. Yeah, and then we add those two. result texture coordinate is equal to floor texel coordinate. Huh. Clamp. Hmm. Texture color. Hmm. Okay. Location within texel. Texels per pixel. Hmm. Okay. Compute how many texels map to one screen pixel. The magic part, yeah. This is doing only blend near texel edges, not everywhere. Yeah, yeah. Exactly. Near center of pixel behaves like nearest. Near edges gradually blends towards neighbor pixel. Yeah. Hmm. Simplify this shader. That's much simpler. Let's try to understand that. Base taxol. Yeah. Fraction inside the taxol. How many taxols fit into one screen pixel? Base taxol. Integer pixel. Let's see. Fraction. Smooth step. I'm not sure about this one. What if taxols per pixel is very high? Why this is better? Smooth step. Yeah. Um, hmm. Interesting. Yeah, okay. I think I understood the general idea. I just want to like finish my understanding. Um, Okay, division location within texel divided by texels per pixel. Location within texel. Location within texel. Okay. Divided by texels per pixel. Divided by the texture size on the screen. So, like if my original image was high, but on the screen I draw it as small, then this will be high. But if my original image was small and on the screen it is big, like I think will be a more frequent situation with pixel art images. Yeah, I think so. This value will be less than 1 usually, or not. Yeah, less than 1 because the size is small, but on the screen high. Okay. Divided by texels per pixel. Now, if texels per pixel location within texel divided by texels per pixel. Oh my god. Why is this so difficult for me? Because I'm trying to understand it. Yeah, so okay. Yeah, so if my image on screen was like 10 times higher than the original image, then this will be 0.1. If I then divide location within texel times texels per pixel, this will be magnified by 10, and if I clamp it to those values, I will understand how close to the edge of the pixel I am, or what? How close to the edge of the texel, probably. Alright. Yeah. Location within texel. Location within texel. Yeah, exactly. This will tell me how close to the edge of the of the text, so I am on the screen. Yeah. Okay. And it will tell me in pixels how close I am. Huh. Interesting. Interesting. Okay. Yeah. Let's see. Let's try to implement this. Oh, the implementation will be fun. I be I I'm sure. Yeah, so I have those UVs. I need some kind of an indication if this is a pixel perfect image. Pixel perfect quad. Hmm. And it is quite an interesting task. Maybe I use uniform variable like uniform bool uniform int. I do not remember if they have bool, but uniform bool manual pixel. How did it call the? Wait a second. How did ChatGPT call this thing? Smooth pixel scaling. Anti-alias nearest filtering. Huh. Oh my god, this shader is so good. F with GLSL. The sum of the absolute derivatives. Hmm. Because you see, the problem is that um, to render this, to implement my version of the shader, I need this uniform texture size on the screen. And actually I never understood those f-width. Let's ask ChatGPT, can this uniform be removed? Is there another way to do the same thing without it? The shader fundamentally needs to know how big the texture appears on the screen. Yeah. Whether you're scaling. Use derivatives. You can compute screen space scaling directly in the fragment shader using. How fast UV changes across the screen. What? How much texel coordinates change per screen pixel? Explain this to me. How this works? Great question. How much does X change when moving 1 pixel to the right on the screen? Oh my god. What? Mm-hmm. How big is 1 screen pixel in UV space? How big is 1 screen pixel? Uh-huh. Interesting. Very interesting. Nice. Yeah. So I guess this guy just did um I don't know what he did. Floor. Hmm. Okay. Hmm. Maybe I should do something like pixel perfect, pixel art. No. Texture load. I'm not sure if I even have to like specify it here. Anti-aliased nearest filtering. Weird. I do not know what to do. Really, I do not know. I'm stuck. Uh, hmm. Let's think about it for a second. If I want to... If I want to do this... maybe I can store per face, like bool, per face boolean. Per face boolean, which will indicate if this face should be like anti-aliased. Yeah, I think this might work. Flat in int anti-aliased nearest neighbor. Why not? Yeah. Anti-alias nearest neighbor. This one will have to output flat out per face data. Per face data. Let's say anti-alias nearest neighbor will be equal to fetched surface data green. Okay. Okay. Now I need to do a lot of things. First of all, I need to create this per face data in my render, in my batcher thing. Per face texture indices. Ooh, sheesh. Per face struct per face batcher per face data. Oh my god, what am I doing? Struct, yeah. Let's say texture index of this type. Texture index. Oh, sorry. Anti-alias nearest neighbor. Will also be a boolean. Okay. Per face data. Per face data. Okay. Per face RG8 UI. Per face texture indices. Size of batcher dd per face data. Nice. Okay. Yeah, really nice. Per face data. Per face data. Maybe like this. Per face data. Per face data. Texture index will be equal to texture index per face data. Anti-alias nearest neighbor. I've lost the place in the code. Help me with that, please. Please help me with that. Where I was. Push quad manual. Right. Hmm. Okay. Okay. I'm thinking maybe it was a better idea to do this per batcher. Maybe not. Hmm. Okay, let's do it this way. It's not a problem. Yeah. Anti-alias nearest neighbor. Push texture. Anti-alias nearest neighbor will be equal to texture. I think I can start per texture. Why not? Maybe texture can have flags. View 32. Texture flags. Anti-alias. Flags. Enum. Enum flags. Oh my god, what is this? Enum flags. Let's see. I do not even understand in Jai what's the difference between with enum flags. Let's see. In Jai, what is the difference between enum and enum flags? Hmm. Nice. I think I like it. I will use that. I will use this. О, Рыж, привет. Сколько находил в итоге сегодня? Texture flag. Anti-alias nearest neighbor. Enum flags. Нормально. Сейчас я гляну, сколько я сегодня находил. Ну, конечно, меньше будет, 100%. 10 800. 10 800. Anti-alias nearest neighbor. Okay. Flags 32, something like that. Okay, and yeah, what should I do now? Now, let's also add such a flag to texture load parameters. Anti-alias nearest neighbor. Boolean equal false. Now, now I will here where I calculate the filtering mode, what I will do, I will do multiple things. I will say if load params anti-alias nearest neighbor, in this case we need to force linear filtering. Yeah, that's it. And we need to say yeah, let's also, no, not here. Yeah. Load params, filtering is nearest, equal false. Yeah, so that here we do not accidentally generate meep maps. Yeah. Because generally I think for pixel art there will only be a need to like scale, not minify, you know. I mean magnify, not minify, because pixel art is pixel art. Yeah. And yeah, I need to save texture anti-alias. Texture flags. Texture flags. equal 0. Texture. Texture flags. How do I do this in Jai? Wait a second. Just Google decade slack HTML. The patent for some super cool text rendering algorithm has expired. Чего у меня чат не отображается? Странно. Window. View. Okay, wait a second. Oh. I think I've seen this on LinkedIn. У меня, кстати, книжка его есть, вот прям на столе лежит. Даже 2 книжки егоных. Но он крутой математик. Okay, let's do the simplest way. If load rams anti-ali лень писать. Then texture flags equal texture flags equal this. I'm not sure if I can write it this way, but never mind. Yeah. Okay. Okay. And I'm trying to render not the text, but I'm trying to actually I will I'm not even sure if I will be able or not. Wait a second. Type mismatch, type given bool. Not a problem. Texture index. say texture alias anti-alias nearest neighbor. Okay. Nice. This is fine for me. Yeah. Yeah, per face data. Anti-alias. Wait a second. Anti-alias nearest neighbor. Equal to texture flags and and main and this. Okay. How is there a way to quickly test the flag in flags? Yeah, no, I was thinking about the same way. I just thought maybe there's a way to do this shorter, but yeah, this is nice for me. Like this. What? Maybe there are errors in shaders. Yeah. Okay. Main dry. Undefined variable to unpack. I think somewhere here. Anti-alias. Undefined variable. Oh my god. Yeah. Okay, still have some errors. Fetched. Okay. Yeah, still see this jittering, but now we will implement the algorithm. Now we will implement the algorithm. We will need to modify this UV. Actual UV equal to VS UV. Now let's say that if anti-alias nearest neighbor not equal to 0, what I will do. So first of all, I will calculate the texture size. Maybe let's get the texture first. Sampler 2D texture. Sampler. Texture size equals texture size sampler 0. Okay. Now let's calculate the texel coordinate. No, the coordinate within a texel. All right. How do I do this? I do this by multiplying coordinate inside texel. This is equal to UV. VS UV times texture size. Fractional part of this. All right. Now that I've calculated this, I need to calculate number of texels per pixel. But for this, I need to know I need to know the ratio between non-texels per pixel equal to texture size divided by texture size on the screen. Yeah, and I've asked he says that texel position let's save this one vector to coord coordinate. How did I call this here? Texel coord. Coordinate inside Texel is the Рыша, чего сообщение удалил? Now, yeah, in this implementation I've used and calculated the size on the screen, but now I want to use those cool features. Texels per pixel. Dx, df, dx. Texel coordinate. Float dy, df, dx. Texel coordinate. Now, yeah, now let's do the next thing. Let's say that vector2 texels, num texels per pixel equal to maximum of ABS dx, ABS dy. Okay, and yeah, now float lerp factor 1 will be equal to clamp coordinate inside texel divided by num texels per pixel. Factor 2 equal to clamp. Coordinate inside texel minus 1. Okay, divided by num pixels per pixel plus and let's clamp it this way. Our factor vector 2 factor 1 plus factor 2. Now let's say that actual UV will be equal to pixel covered plus lerp factor, like subpixel shift, divided by texture size. Okay, and okay, nice. For now, let's do this thing. I just want to make sure that I have this one set for my images. Color equal to vector 4. Let's make it red if this field is set. Of course, I made a lot of errors. Now let's fix them. Okay, not a problem. Implicit narrowing. Implicit narrowing. And floor texel coordinate. Mm-hmm. I do not understand where I dfdy. Okay. Okay. I need to somehow calculate where this error was made. Implicit narrowing of type to float. Somewhere. Hmm. Uh-huh. Oh my god. Okay. Yes, nothing will change for now because first to I need to anti-alias those pixelated load params anti-alias nearest neighbor equal to true. Yes, nice. And the moment of truth. I finally need to reveal the secrets of my shader. Bam. Hmm. Huh. Like, I want to say that it looks better, but unfortunately it is not. Hmm. It, it definitely is much better now, but it is definitely much smoother, but no. Like inside the texture it is much better. But on the outside I still see this flickering. Yeah, not ideal, not ideal. Hmm. Aha. Oh, no, wait a second, I want to verify. Hmm. Yeah, I see. Hmm. Actually, it is working. The problem is that for pixel art images, on the edge, like, you will definitely not be able to notice this, but on the edge, it still has this error. And the problem is that I use texture wrap mode as clamp to edge. In case of usual texture, it is nice, but in case of this texture, in case of pixel art textures, it fails to select, like, if I clamp to the edge, it will take the same color, and this artifact will still appear. And the solution would be to change clamping method. Okay. Should clamp to border. Bool. True. False. Wait a second. Clamp to border color. Color equal to colors transparent. Okay. Maybe something like that. Now I need to define this transparent color. Colors transparent equal to 0. Yeah. Okay. And now when dealing with this, let's see, maybe my previous OpenGL code already contains GL texture text parameter. Yeah. If load params should set border color. Okay. If I need to set it, I will do something similar, texture border color, and of course I need I need to somehow retrieve this float as a pointer. Wait a second. And of course I need to convert my color, which is basically an int, to the float. Vector. Wait a second. Linear color will be equal sRGB to linear. Load params. Border color. And let's take the address of linear color. Linear color X, something like that. Okay. Uh-huh. Maybe, sorry. Do I have sRGBA? Yes, I have one. Nice. Is not a member of texture load params. Load params should set border color. Should clamp to border color. Wait a second. Wait a second, please. Border color. Should set border color. Let's say that we should set border color to true. Load params. To be honest, I'm not really a fan of those modifications. What if I do not want to modify my parameters? What if I want them to be const? Const Const things that are constant. Main joy. Okay, I will like spend some time to maybe somehow making it look good. I can, I think, write it a little bit shorter. Huh, maybe not. If expression, then else linear. Will it work this way? I don't know. Okay. Yeah, border color equal to colors transparent. Yeah, but as I've said, I do not actually want to modify. So yeah, let's set the actual border color to load params border color. Let's say that actual border color will be equal to this. Load params should set border color. Actual border color should set border color will be equal to this one. Should set border color equal to true. Okay. And yeah, I need to somehow Okay, let's just say and no load params anti-alias nearest neighbor. Because when we need to anti-alias, we do not want to generate map maps. right? Or actually, maybe this is not correct. Yeah, because the filtering. Huh. Let's say XX if expression. Filtering. No. If expression. If generate MIPS. Then this one. Otherwise this one. Yeah. And we do not need this one. Force linear filtering. Yeah. Okay. Now if should set border color. Yeah, I think this will do it. Yeah, if we should anti-alias nearest neighbor, we will force border color to transparent. We will set the border color. Oh my god. Is this because of this one? No. I think I think I did something bad. But I do not know what. Hmm. Hmm. Yeah, let's say filtering is nearest equal to load params filtering is nearest. Filtering equal to false. And not filtering is nearest. Okay, this looks good to me, I believe. Yeah, and should set border color if wait a second. Wrap mode of type GL int equal to XX if expression should set border color GL clamp to border, else GL clamp to edge. Wrap mode. Okay. I mean, huh. Жура, пришел котик. Ко мне котик пришел, смотрите. Кича, коча. Хороший котес. I think I still see this artifact. Or not. No. It is absolutely fine. Oh my god, this works super nice. Oh my god. Oh. Oh my god, I did this. Oh my god. Yeah, this shader worked, and I mean, this works like a charm. Oh my god. Oh my god. I've never used those before. And to be honest, I still like I think I kind of understand how they work. Because GPU like executes everything in parallel in like 2x2 blocks, which I believe it calls texels. And it has access to neighbor blocks, and it can like take the derivative. It can like see the amount of change. Yeah. Whew. Oh my god. It is so smooth. I think I can try to show the difference. I can do the next thing. Generate MIPS filtering is nearest anti-alias. Yeah, let's rename those to bad pixelated load params, and we will just need to remove this line, like this line. Yeah, and yeah, let's see, bad Mario and bad Peach. Okay. Okay. Mario. Hmm. How do I want to see this? Hmm. Let's see, like this. Yeah, so the bigger ones will be fine. They are really smooth. Ah, wait a second. No, no, no. I can, yeah, I can say it this way. Bet Mario. Okay, yeah, so Peach will be bad and Mario will be good. I'm sure you will not be able to see the difference, but this this one scales like incrementally. It like snaps. Those pixels snap. Like you can see each step, and this one is so smooth. Oh my god. Oh my god. Yeah. Yeah. It worked. It worked. Oh my god. Oh, sheesh. What is this code? Oh. Okay. Okay. Never mind. This was crazy. Actually crazy. Okay. Yeah. So I think um I think we can call it a day because this is a very nice job. Oh my god, yeah. Yeah. Okay, okay. I think I will finish right here. Oh my god, oh. This is awesome. This is actually awesome. I like I can ah, I really like how it turned out. Oh my god. It is so smooth. Oh man. Whew. Okay, yeah. So thank you guys for watching. Uh, how how long is this stream? Oh my god, 4 hours. Oh man, 4 hours. Holy shit. Okay, thank you guys. Thank you, and I hope you enjoyed as much as I did. Um, yeah, so smooth, and we drew really nice, really nice pixel art. Yeah, thank you. Goodbye, guys.